All right, grade 12s, we're on our fourth day solving polynomial equations with functions and formula. We are using some geometry for the most part today, with formulas that you should be familiar with, though you can find some at the front of your book. There are two options. We can rearrange to isolate and then substitute, or substitute first, then rearrange. I'm a math head. I always like to do that first, but some of you like to put the numbers in and then rearrange to solve. Our first one is a cone, and we have a formula for volume. So if I have a formula of 1/3 pi r squared h, and I have been given two pieces of information and I want to solve for h, we can rearrange it for h first, or we can plug the numbers in and solve. Just for sake of algebra, I'm going to do it my way, and I am going to get h by itself. So I am going to multiply both sides by 3. That means this 3 is going to disappear, and I'm going to have 3v equals pi r squared h. On the right side, I have multiplication. Pi times r squared times h. If I want to get rid of what's being multiplied, I'm going to divide pi r squared both sides. So I am left with h equals 3v over pi r squared. So to get my height, I am now going to substitute those values in for v and r. Remember, pi is a number, and we just need to type that into our calculator. So 3 times 373 is our numerator, divided by pi times 8 squared. It is really nice on your calculator if you would just type it in as you see it. You may want to put brackets there, divide, put brackets there, and actually use the pi button so that you're not estimating pi as 3.14, but you're in fact using many, many more digits of pi. Our h value would be, our top for that division is 3 times 373, which is 1119. And the bottom is 64 times pi. And when I put that into my calculator, that division, I get approximately 5.57. So our height is approximately 5.57. Does that make sense? Yes, it does. 1/3 of pi r squared h would be 373. For the same shape, if I was given the volume and the height this time, but not the radius, can I solve for the radius? So let's write the original equation down. Volume is 1/3 pi r squared h. This time I want to solve for r. So I am going to isolate r first before I put the numbers in. So to get rid of times 1/3, I am going to multiply both sides by 3. So my left side becomes 3v equals pi r squared h. I am multiplying r squared by pi and by h. So to get rid of multiplication, we divide. So I'm going to divide both sides by pi h. And I am left with r squared equals 3v over pi h. To solve for r when I know r squared, I would impose a square root, 3v over pi h. Normally, when we impose a square root, we need to consider the positive answer or the negative answer. But I am talking about radius. Does it make sense to have a negative radius? No, it does not. So we are allowed to discount the negative because we know that it is radius, and it would only make sense to have a positive answer. So let's put in our numbers. My radius will be the square root of 3 times 250 over pi times the height, which is 18. So my radius is approximately 750 divided by 18 pi, and then take the square root. So I'm writing every single step down here. 750 divided by 18 pi. I'm sorry. It's approximately the square root of 13.26, which leaves us with an answer of, square root of my answer, 3.6. You could have substituted the numbers right at the beginning when we had our formula v equals 1/3 pi r squared h. And you could have put 250 equals 1/3 pi r squared and put the number 18. Did I put an 8? Oh, I'm good. Put an 18 right there and solve it from there. You'd be doing the same process. It doesn't matter when you substitute those numbers. For our next example, we have a can, and I'm not entirely sure why my poor can got cut off here. So we're just going to fill in the poor can, such as it is. All right. And we'll make him blue. There. Can of beans. All right. We have a formula for volume of a can. Pi times r squared, which is the area of the circle, the end, times the height will give us the full volume. If we're given the radius is 8 and the height is 20, and I want to solve for volume, that's a nice straight substitution because I already have volume isolated. So I just need to put those numbers in and solve for v. So I am going to do pi times 64 times 20 and type it in my calculator, and I will get pi times 64 times 20, 4,021. If it was meters for the radius and for the height, this is a very large can of beans. Sorry. All right, it's a silo or something. Whoops, my bad. Meters cubed. Part B asks us if the volume is doubled and the height is the same, what is the radius? So for this problem, I have a doubled volume. So I'm going to just write my formula again. Volume equals pi r squared h. My volume is doubled. That means I have 8,042. I want to know the radius, and the height is the same. So I can put a 20 in for my height. I want to solve for radius. So if I have radius squared being multiplied by pi and 20, I'm going to divide both sides by pi times 20. So my radius squared is equal to, I'm going to type in my calculator, 8,042 divided by pi times 20, and I'm going to tell my calculator to put that in brackets so that it does the denominator as one thing. It keeps our order of operations straight. Make your brackets, your friends. 8,042 divided by pi times 20, bracket, 127.99. I'm leaving my answer in the calculator to get less and less rounding errors. I am going to impose a square root on both sides. You know that the radius has to be positive, so I don't have to consider the negative answer. So what I'm actually going to type in my calculator for this is square root of answer, so that I haven't lost any rounding or haven't created any rounding errors. So second function square root of my answer is about 11.3. All right, let's look at the same can, which is really cut off. This poor can, he's having a hard time. Or silo, whatever it is. There we go. And we're going to look at the surface area. There is a formula for surface area. This is the two ends. So you get the area of the two circles on the ends. There should be a 2 there. I missed a 2. And we have the area of the rest of the can, which would be a rectangle if you were to cut it. It's a rectangle that when cut would have a height along the long side and the circumference along the top of the can. So this distance around here, let's use red so your eyes can see it, right around here, if you were to cut that open, would be your width. So that's where the formula comes from, and we want to find the surface area if the radius is 8 and the height is 20. So a nice straight substitution, 2 times pi times 8 times 20 plus 2 times pi times 8 squared. You can type that in as you see it. You can put brackets there. You don't need to, but you should use pi as a button on your calculator for less rounding errors. We should get 320 pi plus 64 and 64 is 132 pi. Whoops, that's 128. Which would be a total of 448 pi. That would be an exact answer. If you're doing a decimal answer, and let me just make an unhappy face, then it would be 448 times pi, which would be a surface area of 1,407. And our units were meters. And since it's area, it's meters squared. But I like the 448 pi meters squared better. What if the surface area is doubled and the height remains the same? Let's find the radius. Okay, so if I have a doubled surface area, then 1,407, we could double that, or 448 pi, we're going to double that. 448 doubled would be 896 pi. And this is an exact doubling because we haven't rounded, so I can say equals. The height remains the same, and the height was 20, and it's the radius that I want to find. So I've got 2 times pi times r times 20 plus 2 times pi times r squared. And I want to solve for r. The first thing that I'm going to do is to divide every term by pi. That just gets rid of the nastiness. So we would have 896 equals 40r plus 2r squared. I want to solve for r. What are our strategies to solve for r? Well, the first thing we're going to do is subtract 896 from both sides, and I'm going to change the order. So it's in the order that we're used to, 96. If I want to solve for r, the first thing that I would do would be to factor that thing. 2 times r squared plus 20r minus 448. If you could factor further, you would see your two values for r. I took a minute and tried, and I did come up with some nice factors. So we're going to be lazy, and we're going to look at answers for r by using the quadratic formula. So to solve for r would be negative b, which is negative 20, plus or minus the square root of 20 squared minus 4 times a, which is invisible 1, times c, which is minus 448 over 2a. So r is minus 20 plus or minus square root of, and this one's going to be big, 20 squared is 400. I do my signs always first. Take away positive times negative is going to end up being a positive, and 4 times 448 is 1,792 over 2. Negative 20 plus or minus, almost done. Square root of 1792 and 400 is the square root of 2192, which is not a really pretty number. Square root is about 46.8. We know that we're looking for a radius. So negative 20 take away 46.8. It's a very largely negative number divided by 2 is going to be negative. So we can discount that answer and just do the positive answer, which is radius is negative 20 add 46.8, which will give you a positive, divided by 2 will still be positive. That will be our radius. Negative 20 plus 46.8 is 26.8 divided by 2 is about 13.4. If you have a radius of 13.4 as opposed to a radius of 8, does it make sense that our surface area will double? Yes, it is certainly reasonable. So we have solved for the radius. Last example, we've got more of a physics example. So this is straight out of a physics textbook. S is your displacement, or how far you have gone, equals ut, where u is your initial velocity, a half, sorry, that got a little screwy, a half your a, as you would think, would be your acceleration. Okay, so we have a scenario where Buddy travels 480 meters in 10 seconds from rest. What is his acceleration? So we have a displacement, so that is how far he went, so that would be our S. 10 seconds would be your T, and from rest is indicating your initial velocity is 0. So we've got lots of stuff. We want to find the acceleration. All right, this example, I'm going to put the numbers in first and solve for A in a moment. So I have 480 equals U. My initial velocity was 0 because it was from rest, so that UT is going to be 0. So I've got a half times acceleration times 10 seconds, and your time is squared. So if I want to solve for acceleration, I'm going to get rid of the half and rid of the 10 squared, which is 100. I'm going to do one at a time. To get rid of a half, I'm going to multiply both sides by 2. So I have 960 equals A times 100. Dividing both sides by 100, I am going to get A is 9.6. And my units would be meters per second squared, which means meters per second. That would be my acceleration. So for the same guy, we're going to find the distance traveled. So we're going to find S. So how far did he go in 12 seconds? So we knew he went 480 in 10. How far did he go in 12? We have the same acceleration. So we've got our A equals 9.6 meters per second squared. We know our initial velocity is 0. And we want to know, and T is 12, we want to know the displacement. So we're going to do a substitution where we are actually solving for S. And we have 0 times 12, so that's just 0, plus a half times the acceleration is 9.6, t squared is 12 squared. So let's solve. 0 times 12 is 0. A half times 9.6 times 12 squared. A half times 9.6 is 4.8 times 12 squared is 144. Final answer is 691 meters in those 12 seconds. That is reasonable when we know that he went 480 meters in 10 seconds. How long does it take him to travel 600 meters? So we are solving for t. If his displacement is 600, his initial velocity is 0, so that 0 is really going to just disappear, plus a half, where'd it go? Half at squared. And our a was 9.6. That's what we are trying to solve. So the 0t is not there. A half times 9.6 times t squared. If I want to get t squared by itself, I'm going to multiply both sides by 2 to get rid of the fraction. So I have 1200 equals 9.6 t squared. I would divide both sides by 9.6. And that would give me my t squared. 1200 divided by 9.6 is 125. I'm going to impose a square root on both sides, so that will give me t is the square root of 125. And it makes sense in the problem that t would be a positive number, so I don't have to consider the negative square root. I just need the positive value. And I get 11.2. So in 11.2 seconds, he can go 600 meters. And that answer should lie between the 10 seconds and the 12 seconds. And the distances were 480 to 691. So that answer falls squarely in between the two. We have solved it correctly. It is reasonable. Some good questions to try. You should have a great time with these. Page 121 and page 125. Some geometry and light questions.